So in this video, we're going to look at an application of what I've been calling in this class the key calculus formula. Okay, and the key calculus formula is that f of x plus h is approximately equal to f of x plus the derivative of the function times h. This is our key calculus formula. Okay, we have used that key calculus formula to get a good idea about how to take the derivative, for example, of a function x to the n, where n is a positive integer. And this is what we're calling the power rule. And we know from a previous video that the answer for the derivative, that is, if the function is x to the n, then the derivative function is n x to the n minus 1 power. And that was an application of the calculus formula. Okay, here is a question that is a natural follow-up. Question, what is, if you're given the function f of x is, say, 5x to the 6th power, right? What is f prime of x equal to? Okay, and you might have a good guess at this answer, but I just want to make a note here that if you're looking at the 5x to the 6th power, you're noticing that there is an x to the 6th power, in this problem. And then we know that if you were to take the derivative of x to the 6th power, you would get 6x to the 5th. So what I'm claiming is that if you're seeing the x to the 6th, you know that derivative via the power rule. Okay. A natural question is, when you see this function f of x, you'll notice that it is a constant 5 times the x to the 6th power. So this is of the form a constant times a function constant times another function g of x. Right? So we're seeing f of x, 5x to the 6th, as a constant times another function g of x, and it is the derivative of g of x that we actually know. This is known. But the question is, what is the derivative of the constant times that function? Okay, and my claim is that I'm going to show you how to use this calculus formula. I'm going to let big f of x, I'm going to define this function to be a constant k times f of x. Okay, so I'm going to make a new function. Okay, I'm going to make a new function. Okay, and the question, once you have a new function, the question is, what is the derivative of that function? Okay, and my claim is that if you want to find the derivative of a function, okay, my claim is that since we probably know that the function f of x, right, we know that its derivative can be found by computing f of x plus h is approximately f of x plus f prime of x times h, where we know the function little f of x and we know its derivative is from the expansion, the quantity that shows up in front of the h. My claim is that since we know that, I can try to find the derivative f prime of x by doing the expansion of that function big f of x. But big f of x is a constant times the little function f of x, but wherever you see the x, you need to put in x plus h. And since the little f of x function can be approximated as f of x plus f prime of x times h, right? And we can then distribute the constant k through, you get k f of x plus k f prime of x times h. And because we know that the constant k times f is this big function f, right? And we can see here the quantity in front of the h. What we can say here is that big f of x plus h is approximately the function big f of x plus something multiplied by h, where the term that's in front of the h is the derivative here is the derivative of the big function big f of x. And this implies in this problem that if you're going to take the derivative of a new function, which is a constant times a function, all you have to do is take that same constant and multiply it by the derivative that you know about. Okay? This is the practical application of that calculus formula. Okay? So for example, here we have a problem, right? Here u of x is a new function, right? This is a new function, and the known function is in pink here. The known function is the x cubed function, and the new function is a constant pi to the fourth multiplied by that known function. And what I mean by known, I'm saying that if we're trying to find the derivative of pi to the fourth multiplied by the function x cubed, we know that, according to what we just showed, that the constant, right here, can come out in front of the derivative, and we can just instead take the derivative of our known quantity x cubed, which is equal to, by the power rule, 3x squared, which tells us that our answer is, for the derivative of the function u of x, is pi to the fourth multiplied by 3 multiplied by x squared. So what we're saying here is that if the function u of x is pi to the fourth times x cubed, then the derivative of that function is the constant pi to the fourth simply multiplied by the derivative of the known function 3 pi to the fourth x squared. Okay, so that is an important application of the key calculus formula. Okay, there is another a result that we should probably discuss, right? Here is a new function. I'm going to call it big f of x. This is a new function. And this new function is going to be made of two smaller functions that you know about, f of x plus g of x. And let's assume that you know something about these functions. Assume that you know f prime of x. And assume that you know g prime of x, right? And where are you getting those derivatives, f prime and g prime, from? This is what we're assuming, is that we're knowing that the little function f of x plus h is approximately f of x plus its derivative function times h when we do the expansions and do the approximations. This is what we're assuming that we know. The question is, right, for this new function big f of x, what is the derivative of the function big f of x? And my claim is that if you want to figure out what is the derivative of that new function, my claim is that you need to do the expansion f of x plus h. But big f of x, this new function, is the function f and the function f and the function g. But we're supposed to evaluate those at x plus h. Okay? But we're going to do an approximation problem. F of x plus h is approximately f of x plus f prime of x times h. And then there is another term, g of x plus h, which can be approximated as g of x plus g prime of xh. Now look at this, a little bit of algebra, reorienting these, because addition can be done in any order. There's f of x plus g of x. We can see here that there are two terms that have h in them, so we'll factor it out, and then we get f prime of x plus g prime of x. So this tells me that f, this new function evaluated at x plus h, is approximately equal to this thing which we recognize, f plus g, is the function f itself, big F. And that makes this quantity in front of the h, makes this quantity in the box the derivative of that new function. Okay, so what this means is that the derivative of this new function f plus g is the derivative of the one function you know, the derivative of the other function you know, added to each other. Okay. In other words, the derivative of two functions added to each other is the derivative of one of the functions, the derivative of the other function, add the two derivatives together. This is a result called the sum rule. Okay, and it can get applied as follows. Okay, so for example, the sum rule. Okay, I'm going to make a function. I'm going to call it S for sum. I'm going to say that this function is two functions added to each other. So let's make it 3x to the fourth minus 5x squared. Okay. What's the derivative of this sum function? Well, this sum function is made of two functions separately. Right? There's a function f and a g, and they are summed, which is done via subtraction. Subtraction is the opposite of addition. So if we want to find the derivative of the sum function, what we need to do is to take the derivative of the function f, the derivative of the separate function g, and we get to subtract those two results from each other. But this problem is nice and easy because we have the power rule. The derivative of 3x to the fourth is 12x cubed. The derivative of the other function, 5x squared, is 10x, and we get to subtract those two results together. So this function here, right here in the box, is what we call S prime of x, the derivative of the sum function. Now, you very likely would have just guessed this result. If you had a function like this, you probably would have immediately written down the sum function, the sum rule. Take the derivative of each part separately. Okay, so it is another question and the point of another video to talk about what is the derivative of a product function, P.